Okay, Assalamualaikum and morning to all. Okay. So I'm so sorry hari tu kita tak boleh buat kelas sebab saya busy sangat dengan FYP2 punya submissions. Okay, we have a few masalah. It's not really masalah sebenarnya sebab kebanyakan tarikh for the submission bertukar, so a bit hectic sikit lah, banyak kerja nak kena ubah-ubah and everything. Alright, so again, so this is the last chapter in our syllabus. Alright, so EM wave propagation ataupun electromagnetic wave propagations. So before this, we learn about the electrostatic, okay, the electric field intensity and so on. And then next we learn about the magnetostatic for the magnetic field and so on. And then we have this apa lagi, kita ada Faraday law, okay, and now is the last one, which is the combinations of the magnetic and the electric field, okay, and it will produce what we call as the EM wave ataupun magnetic wave. Okay, so this electromagnetic wave is the combinations of magnetic field and also electric field. All right, so if we go to the introductions, right, so electromagnetic wave are widely used in engineering applications, of course. So we use in the form of applications such as the wireless communication. So wireless communications, it's include your phone, all right, your signal broadcasting, TV and so on. Okay, and then we have, other than that, we have for radar, we have for space explorations and everything. Okay, and then this wave propagation is any of the ways in which wave travel. Okay, so we can see that in this chapter. So we will look into how the properties of the medium affect the propagations of wave, ataupun kita tengok macam mana the wave move in a medium atau different type of medium for this wave transmit. Alright, so okay, so a wave can be transverse or longitudinal, okay, depending on the directions. So it can be two, okay, so either transverse ataupun longitudinal, okay. And then our what is the difference between these two is that this transverse wave is the oscillations of the wave ataupun macam mana the wave travel, it is parallel to the directions of propagation. So the contoh is like a sound wave. Okay, so you can see here. Saya terbalik ke letak? Sekejap ya. Okay, you can see here. Mana dia tadi? Okay. Okay, so it's either transverse ataupun longitudinal. So kalau kita tengok longitudinal, the wave occur when the oscillations are parallel to the directions of propagations. Okay, and a transverse wave is moving perpendicular. So satu adalah parallel, satu adalah perpendicular. Alright. Okay, so okay, so an electromagnetic wave is a transverse wave. Okay, so maknanya kalau dia adalah transverse wave, so it is travelling perpendicular to the directions of the wave propagations. Okay, so we can see here, this is the examples of a transverse wave ataupun kita punya electromagnetic wave. So you can see that as I said just now, for the transverse wave, the oscillation is perpendicular to the directions of the energy. So what does it mean by that? So if we look into the directions of the wave, let's say the wave travel in y directions to here. Let's say this is y directions. And then we have this electric field in orange color and the magnetic field in a purple color. So you can see that the directions of the magnetic and also the electric will be different. So the directions of this electric field is, let's say, going up here is z directions, and these directions of the magnetic field will be in x directions. So you can see here, yeah. So directions of this magnetic field is in x direction, and then this electric field will be in z direction, and directions of the propagations wave will travel to y direction. So it's going this way. Okay, so this is also the examples of the longitudinal wave. Okay, so you can see that the wave is travel parallels to the directions of propagation. So you can see how the wave looks like when it's travel. So kalau kita for the EM wave, this is the EM wave, transverse wave. So you can see that we have a sinusoidal types of wave like this. Okay. All right. So two main features of electromagnetic wave. So electromagnetic wave will contain, as I said, electric field and also magnetic field, and it's carry energy ataupun it carry the informations. Okay. And then wave in general, so in here we can see the type of medium where your wave travels. Okay. Medium is a material which help the energy transfer from one location to another. So you can see that this medium can be divided into two main categories. One is lossless and another one is a lossy medium. Okay, so you can see in this block diagram. So one is lossless and another one is lossy. So what the difference between those two is that you can see here for lossless, it also can be divided into two again. One is when the signal ataupun when the wave is transmit through the free space. Okay, macam your wireless transmission. So that will be in the free space. Okay. And then another one, it's still under a lossless medium, but we call as the lossless dielectric. So this one is the example for this is non-magnetic dielectric, where the signal is transverse through this medium, but it is not exactly like free space. Cumanya dia ada a dielectric, so maknanya the medium will travel through the dielectric medium. Right. So another type of medium, what we call as a lossy. So lossy also can be divided into two. One is lossy dielectric. Again, we have lossy. We also have dielectric in the lossy medium. Okay, and then another one is a good conductor, where it will transmit your signal by using a conductor. Okay, and then from here, how we see that the signal or the wave travel, it's depending on the parameters that involve in all these mediums. So you can see that this behavior of the mediums is depending on the so-called like parameters, which is we have the conductivity, we have the permittivity of the dielectric epsilon here, we have the permeability, your mu, and then we look into what is the frequency, and we look into the phase constant, and many more we go through afterwards. Okay, and then we can see here, this is the example of the wave. Okay, so if you look here, we can say that from this point to this point is lambda ataupun what we call as the wavelength of the wave. Okay, and then in the same scenario, okay, so for this one is the amplitude versus directions ataupun versus distance, sorry. So this is the amplitude versus distance, and this is the signal where the amplitude versus time. So if we take the same the same measurement from this lambda into this signal ataupun this wave, we can say that the same amount of lambda ataupun one lambda will be equals to one time of period t. Okay, period of time t. Alright, so it will be the same. Okay, so this is the explanation. So indicates that the lambda to repeat itself is called as the wavelength, okay, and then show that wave takes time t to repeat itself, and t is known as the period of time and measured in second. Okay, so how we relate between this lambda and also the period of time, we can have this equation where lambda is equal to mu t, where mu is the speed or the velocity. Okay, and then we have t is equals to 1 over f. All right, and then we have u ataupun the velocity just now will equals to lambda over f, lambda f. All right, and then we have this omega, which is the angular frequency in the unit of radian per second, which is 2 pi f. And then also we have this phase constant beta in radian per meter. Okay, and this is the equations for beta where we have 2 pi over lambda. All right. Okay, so all this shows that every wavelength of a distance travel, okay, so banyak mana the wavelength distance travel, a wave undergoes a phase change of 2 pi radians, okay, for this one. Okay, so banyak mana the distance kita travel, a wave for a single wavelength, okay, a wave undergoes a phase change of 2 pi radians. Okay, so we can see that, okay, setiap wavelength ni dia akan tukar. Sekejap dia dekat atas, sekejap dia dekat bawah, sekejap dekat atas, sekejap dekat bawah. Okay, so that is what dimaksudkan yang undergoes a phase change of 2 pi. Right? Okay, so we go into this wave propagation in lossy dielectric. Alright, so kita ada 4 tadi ya. So this is the first one. Okay, so as already stated, wave propagation in lossy dielectric is a general case from which wave propagation in other types of media can be extracted as special case. Okay, in a lossy dielectric, as it propagates, losses power owing to imperfect dielectric. So whatever signal, let's say we transmit this amount of signal with this amount of amplitudes. So as it travel through the space ataupun through the medium, and not space, through the lossy medium, okay, the signal amplitude will be decreased. Okay, so saya ulang. So whatever amplitude yang kita transmit at first, let's say this amount of amplitude. So as long as it travel along a distance, the signal amplitude will be decreased. Okay, why is it decreased? Because it's travel through the lossy medium ataupun lossy dielectric. Okay, so you can see that how the signal amplitude will be decreased. Okay, so lossy means the poor conductance property of mediums, right? Okay, so this electric field, so again, this electromagnetic wave is a combination of electric field and a magnetic field. So you can see that this is the equations for the electric field. All right, so we have E Z T equals to E naught E negative alpha z sine omega t minus beta z, and the directions is ax. So you can see that this is the electric field punya equations. So EZT meaning that Z is uh, the directions of the wave propagates, or you can see here also. So beta Z, so Z here meaning that the wave propagates towards AZ directions, and this AX is the directions of E fields. Okay, so remember that. So Z is showing here, Z ni maknanya the directions of the wave propagations is in Z direction, and the directions of this electric field is AX directions. Okay. So we can see here what is E naught. So E naught is the amplitude of E. Okay. So E naught here, this main part here, E naught epsilon minus alpha Z, this is the amplitude of the wave. Okay. All right. So we have this amplitude of E, and then we have alpha. Alpha is the attenuation constant ataupun attenuation coefficients. Okay, beta just now we know that that is the phase constant ataupun the wave number. All right, and this is all the definitions. I think you can read it yourself. And then we have this gamma, what we call as propagation constants, and we have gamma equals to alpha plus j beta. And then next to that, we have this magnetic field punya equations. Okay, so we have Hzt equals to H naught epsilon power of minus alpha z sine omega t minus beta z and minus theta n. Okay, theta n is the intrinsic angle, and then the directions of your this H propagation is AY. Okay, so E tadi directions of propagation dia adalah AX, but for H directions of propagation dia adalah AY. But the directions of the wave, the combinations of electric field and magnetic field will be Z. Okay, still will be Z. Alright, so H naught is the amplitude of H, sama macam E tadi. But how to find H naught is that it is equal to E naught over the intrinsic impedance. Okay, and then intrinsic impedance ni normally kita ambil the positive value sahaja. Alright, so this is the intrinsic impedance, and then this is the angle of the intrinsic angle. Okay. Alright, so this is all the definitions. I think you can read it yourself. So we have another one is we have the loss tangents. So this loss tangent is to determine whether your lossy medium, whether it's a lossy dielectric ataupun a good conductor. So how to find that is by looking at this loss tangent. So it is high conductivity ataupun good conductor when the value of this loss tangent is larger than 1, but when this loss tangent is less than 1, maknanya dia adalah low conductivity, so it will be lossy dielectric. Okay, so ada kat sini lagi. So when it's larger than 1, it is a good conductor. When it's less than 1, it's a low loss ataupun lossy dielectric. Right? So we have this theta equals to 2 theta n ataupun 2 intrinsic impedance punya angle. Okay, so next will be the plane wave in lossless dielectric. Alright, so tadi adalah lossy, now it is a lossless. So for the lossless, you know that this is for lossless dielectric. Again, lossless dia ada dua, one is free space and another one is lossless dielectric. Alright, so for lossless dielectric, we know that this all this value, okay, of angle and everything, so will be 0. Okay, and this is the main ataupun the general equations for lossless dielectric. Okay, so just now we have E equals to E naught and then epsilon to the power of minus alpha Z and so on, right? So because of this one is all zero, so that's why we don't have this epsilon punya value dekat sini. Alright, so we just left with E naught sahaja. Okay, so if kalau kamu terjumpa in any questions that the general equation of the electric field is like this, so it means that it will be a lossless punya medium. Okay, so we have lossless electric field, so E naught sine omega t minus beta z ax. Okay, again the directions of the wave propagation is z and the directions of the electric field will be ax. So kamu tengok sini then negative beta z, so meaning that the direction is positive z directions. Kalau dia plus beta z maknanya the wave propagate in negative z directions. Okay, dia terbalik. Alright, so we have next is H. So H naught sine omega t minus beta z and directions dia adalah AY. Okay, so this is all the parameters used untuk kita cari the phase constant, the lambda, the intrinsic impedance, so on for the lossless dielectric. Alright, so this is in free space. So free space again using the same equation of this. Okay, E z t E naught sine and then H z t H naught sine blah blah blah. Okay, so in free space pun guna the two equation juga. Okay, and then other than that we have this beta with this equation and then dia punya intrinsic impedance is 377 ohm and then lambda dia adalah 2 pi over beta. Alright, so that will be in free space. And then we have a good conductor. So again, good conductor is under the lossy medium. So for this one, you need to refer to the equations of the same as the lossy medium tadi, which is this, okay? This E and also this H. That is also for the good conductor punya equations. Alright. Okay, so we go back. So again, a good conductor, the loss tangent will be larger than 1. Okay, and then this is all the values. Alright, and this is all the parameters that you need to use when you when you have this good conductor punya medium. Alright. Okay. And then here we have yeah. Okay, so here we have this what we call as skin depth. Okay, skin depth is a measure of depth to width to which an earth electromagnetic wave can penetrate the medium. So is a measure macam mana ataupun how strong is your wave. So kalau to look into how strong is your wave to go into a certain medium. Okay, so skin depth is a measure of depth to which the EM wave can penetrate. So sejauh mana that your wave can penetrate in a medium is called as a skin depth, and this is the equation for skin depth. Okay, 1 over alpha. All right. Okay, and another important one that you need to know is that you can see here. So in general, so before this, we have a cross product where we have X, Y, and Z, right? Okay, X, Y, and Z, and then we have rho, phi, and theta, and so on. Okay, for different coordinate system. But in this wave propagation, normally we compare it to the Cartesian coordinate where we have X, Y, and Z. Okay, and I hope that you still remember how the cross product works, where we have x, let's say we have x, y, and z. When x cross with y, you will have z directions. When y cross with z, you have ax directions, and when z cross with x, you have ay directions. Ataupun if it's counterclockwise, it will be in negative directions. So same goes for this one. The only thing is that you need to know that, okay, like just now I said to you that the directions of the wave is in z directions, and directions of the E is in x direction, and the directions of your H will be in y directions. Okay, so you can see here. So kalau K cross dengan E, you will get AH. But depending on your what is your K, what is your E, and what is your H. This is the bukan equation, but this is to help you on how to find what is the directions of your propagations. Okay, so you can see that if K is the directions of your propagations, wave propagations. So AK cross AE, you will get AH. Okay, if AK cross dengan AH, okay, so you will get negative AE because it is the other way around. All right, so AE cross AH, you will get AK. Okay, all right. So we look into this example. Example number 1. Okay, so we have, if we have a question like this, okay, this is a simple question. So you are given with a uniform plane wave propagating in a medium of this, and if the medium is characterized by ER is 1, mu R is 20, and then the conductivity is 3, and then find alpha, beta, and H. So normally, when you are given with one electric field or the magnetic field equations, you need to find another equations for, like this is E is given to you, so you need to find H. If H is given to you, you need to find E. So normally the question is like that. All right, and then you need to find a few other parameters. Okay, so first, if you are given with a questions, normally you were given with a equation like this. So first thing you need to know, you need to determine whether this is a lossy ataupun a lossless medium. Okay, because dekat the question here dia tak mention pun whether this is a lossy ataupun this is a lossless. Okay, so if that is the case, okay, dia tak mention, so you need to look into the equation. So if you look into this equation, E equals to 2 epsilon negative alpha z sine 10 power of 8 t minus beta z, and the directions is AY. So from here you know that dia ada this part which is E epsilon negative alpha z. So this one shows that this is a lossy medium. Okay, because dia ada this part epsilon negative alpha z. So from this equation you know that the wave is propagating in a lossy medium. So for that, okay, so you already know that this is a lossy medium. Now, for lossy medium, kita ada dua tadi, right? One is lossy dielectric and another one is a good conductor. So which one yang kamu kena tengok? Is it either a good conductor ataupun is it either a lossy dielectric? So how to determine that is by by looking at the loss tangent like I said just now. So you need to find the value of this one, the loss tangent. So you know that this conductivity just now is given to you 3. So omega you can find it from here, 10 power of 8. Okay, so that will be your omega. All right, and then you have your epsilon. So epsilon tadi dia ada bagikan, epsilon ER is 1. Okay, and then your epsilon node will be 8.854 times 10 power of minus 12. So epsilon meaning that epsilon naught time dengan epsilon r ya. Okay, so this is epsilon r equals to 1, this is epsilon naught. So from there kamu solve it and you will get the value is 3388. Okay. So this only this equation saja. Kamu jangan cari theta dia ke apa. You just find this one, conductivity over omega epsilon. So the value will be 3388. So this 3388 is larger than 1. So because of that, this is a good conductor. So the medium used here is a good conductor. Okay. So next, again, saya lupa nak mention tadi, all the parameters yang given to you tadi, yang dekat atas, whether is a good conductor, free space, lossy dielectric, lossless dielectric. So you can use your appendix. Saya ada bagi appendix, right? So dekat appendix tu semua ada, all the parameters tadi, you can have a look at it. Okay, so all the parameters ada kat situ, so it will help you to answer the questions. Okay, so this is a good conductor. Okay, so when it is a good conductor, so you can refer to your appendix. So you need to find what is the equations for alpha and beta because the question want you to find alpha and beta. Okay, so if you look into your appendix, okay, so go to your appendix, looks into the good conductor punya part. You can see that alpha is equal to beta where you have these equations. Okay, so you have these equations. So it also can use these equations. All right, so you just substitute the value. So this is using this one. Okay, so we have 3 for the conductivity just now, and then 20 for your mu r, and then 4 pi times 10 power of 7 is mu naught, and then we have your 10 power of 8 for the omega, and then divide by 2 and you will get 61.4. Okay, so again refer to your appendix to look into the equations for alpha and beta. Alright, so because of alpha is equal to beta and the answer is 61.4 for both. So we have alpha in unit meters per meter and beta in units radian per meter. Okay. Alright, so next question, you need to find H, the equations for H. So you know that the first thing, you please write down what is the equation for H, the general equation for the lossy medium for H. So this is the general equations where we have H zt equals to H naught epsilon negative alpha z sine omega t minus beta z minus theta n, direction is AY. So this direction will be determined later. So just letak dulu AY. If nanti bila kita cari, okay, using this kita cari, then baru kita letak whether it is betul AY ataupun tidak. Alright, so here this is the equation. So how you need to find H naught. So refer back to the equation earlier. So how you can find the value of H naught is by using E naught over the intrinsic impedance. Alright, so because of you need the value of intrinsic impedance, so that's why here you need to find the intrinsic impedance first. Okay, so but using this equation, again look into the appendix in good conductor punya part, so you can find what is the equations for the intrinsic impedance. So you just substitute the value. Again, omega is 10 power of 8. Your mu r is 20 and mu naught is 4 pi epsilon 10 power of minus 7 divided by your conductivity 3 and you will get the value is 28.94. So that one you just substitute inside these equations. So your E naught is 2. So go back to your ni. So your E naught is 2 here. It's 2, right? What is it? So 2 divided by the intrinsic impedance, so you will get this value. Okay, so bila kamu dah dapat ni, okay, so you know what is the amplitude of your H. Now is to determine the directions of your propagations. Okay, alright, so in order for you to determine, you need to know what is the directions of wave, what is the directions of E, which is your AK and your AE. Okay, so go back to your original signal here for E. So you have E2 epsilon alpha Z sin 10 power of 8 T minus beta Z, and directions dia adalah AY, dia tulis kat sini. So the directions of your wave propagation here, it is AZ, okay, and then the directions of your electric field will be AY. Okay, again, your directions of your wave propagation will be Z, and then directions of your E field will be Y. Okay, so that we have, you need to find directions of AH. So refer back yang tadi tu, untuk cari AH, so you need to look into AK cross dengan AE. Okay, refer back yang saya bagi tadi. So you have AK cross dengan AE. Alright, so if you look here, saya buat again. So AK cross dengan AE, you get AH. AE cross AH, you get AK. AH cross dengan AK, you get AE. Okay. So again, because kita nak cari AH, so AK must cross with AE. So you know that directions of the wave ataupun propagations of the wave tadi for AZ pula. For AK is directions of propagation, wave propagations is AZ. So we just put AZ here. And then this AZ is crossed with AE, and the directions of AE is AY. Okay, so directions of the wave is AZ just now, and directions of the electric field is AY. So if we look back, AZ cross dengan AY, so AZ cross dengan AY, which is anti-clockwise, you will get negative AX. Okay, so AZ cross dengan AY, so here AZ cross dengan AY, you will get negative AX. So because of that, the directions of your H will be negative AX. So you substitute all the value just now, so you have this is your amplitude. So your amplitude will be 69.1, and then we have this E epsilon alpha Z. So you know what is your alpha just now. Alpha beta kita dah cari. So your alpha is 61.4 Z. So refer balik dengan this general equations. Kamu just tulis balik semula. Okay, so this is your amplitude. This is your alpha. Masukkan all the value. And then you have your omega, and then this is your beta. Okay, so this is beta. Okay, this is your beta, and then this is your intrinsic impedance angle. Okay, intrinsic impedance angle is pi over 4. So kenapa pi over 4? I think kat sini dia dah bagi tadi kot. Tak ada ya. Ataupun oh ya. Pi over 4 because in good conductor. So again, refer back to your appendix. You can see that your intrinsic impedance angle will be 45 degree. So it will be pi over 4 because dia dalam radian ya. So pi over 4 kat sini for your intrinsic angle. Okay, so next one. Why kita cari AH here just now? Okay, kenapa kita nak cari AH? Because kita nak tentukan what is the directions of your H field. Okay, kalau ikut the general equations, okay, so this is just a guideline. So this dia tulis kat sini adalah AY. Okay, this is the general one. Kamu jangan ambil terus AY kat sini. Kamu kena cari untuk determine dia. So bila kamu cari, you know that AK tadi adalah AZ direction, AE adalah AY directions. Of course, your H will be AX direction. Cumanya kita nak tahu adakah dia negative AX ataupun dia positive AX. So that's why you need to find. Okay, so bila kamu cari, you found out that the directions of H is negative AX. So that's why negative kamu letak kat depan ni. Boleh juga kalau kamu nak letak sini, either way. Tapi it's better kalau kamu letak sini. So negative 69.1 epsilon E 61.4 Z. So this is your alpha. This is your omega again. This is your beta. And this is your intrinsic impedance. And then if we look into your amplitude, it's 10 power of minus 3. So that's why dia ada milliampere per meter. Okay, so we have milli over here because of this amplitude value is 10 to the power of minus 3. Alright, so boleh faham semua? Faham tak? Ada yang tak nampak? Boleh ya? Alright. Okay. Okay, so remember again, kamu tak payah ingat semua the equation because the equation is in your appendix. Just you need to determine whether dia adalah lossy ataupun lossless. Okay, so kalau dia adalah lossy, you need to determine the loss tangent like this. Okay, cari loss tangent dulu untuk determine whether dia adalah lossy dielectric ataupun good conductor. Then you can proceed to look into the equation for which one yang kamu nak cari. For the lossless medium is free space and lossless dielectric. So for that one, normally dia akan kamu akan diberitahulah the wave is in free space propagations ke, ataupun dia kata the wave propagates in non-magnetic dielectric. Okay, non-magnetic meaning that dia adalah lossless dielectric. Okay, ataupun you can look into the equation itself where dia tak ada epsilon punya part ni, so that will be free space ataupun free space. So that will be the lossless medium. Alright. Okay, we go to the next one. So this is example 2. So example 2 is showing for the lossless dielectric. Okay. So again, in here, a plane wave in non-magnetic medium. Okay, ni macam yang saya cakap tadi, kalau dia stated here non-magnetic medium, meaning that dia adalah lossless dielectric. So remember that. If it is a non-magnetic medium, it will be lossless dielectric and has the equations for E, which is this one, E equals to 50 sine 10 power of 8t plus 2z ay. So you can see that dia tak ada epsilon. Alright, so bila tak ada epsilon, of course dia adalah lossless medium. Okay. Alright. So the first question is that you need to determine the directions of wave propagation. What is the directions of wave propagation? So go back to the equation yang dia bagi ni. So you can see that, as I said before, the directions of wave propagation, you need to look into this part. Okay, so this is omega t plus dengan some value with, this is beta z. Okay, 2 is beta. And Z over here is the directions of the wave propagations. Okay, so is it positive directions of Z ataupun negative directions of Z? You can look over here. Kalau ikutkan, okay, so here. So kalau ikutkan the general equation, kenapa dia letak lah? Okay, kamu tukar balik this equation. Jangan ambil yang ni. This is for the lossless sebab dia ada epsilon. So you just take the equation yang lossless punya equation. So you can, kita go back ya, sekejap ya. Okay, this one. Mana tadi? Ni. Okay. So if we compare the equation between the general one with the one yang dia dah bagi, okay, you can see that if the general one is minus beta z and the E given to you is plus 2z, so it's meaning that the directions of your wave will be negative z, sebab kat sini jadi positif, plus kat sini sebab dia punya equation yang asal is negative beta z. So that will be negative z directions. Okay, the opposite way kan. So it will be negative z directions. Okay, so you look here. So this is z. Okay, so kalau ikutkan asal dia adalah negative beta z because of given to you is plus 2z. So it means that your direction will be negative z directions. And then the directions of your E field will be AY. Okay, right. The next one you need to find lambda. Okay, lambda, frequency and also epsilon R. So because of, you know that this is non-magnetic medium, so refer back to your appendix, go into the lossless medium and look into the lossless dielectric. Okay, so you can see that what is the equation for your lambda. All right, you can find what is the equation for your frequency and also your epsilon R. Okay, so this is the lambda. So lambda is just 2 pi over beta. So you can see from your equation, your beta is 2. Okay, beta dia adalah 2, bukan negatif 2, 2 saja ya. Yang negatif tu is referring to the direction z. Okay, so 2 saja. So you just take 2 and then you will get the lambda, the value of your lambda. Okay, and then the next one you need to find frequency. So this frequency you can just use the equations of omega equals to 2 pi f. Okay, so you can find your f over here. So f is equals to omega divided by 2 pi. So omega again you can find from your equation given to you. So 10 power of 8 is your omega divided by 2 pi. So this is your frequency. And then you need to find your beta. So again refer to the appendix. Bukan nak cari beta, kamu nak cari epsilon R tadi kan, the next questions. So you can use either mana-mana equation pun boleh daripada your lossless dielectric tadi untuk cari your epsilon R. So you can use mana-mana yang sesuai untuk cari epsilon R. So in here it's using beta equals to omega mu times epsilon and square root the thing. Okay, in order for you to find epsilon R. Alright, so epsilon R, kamu just masukkan the value, so you will get epsilon R is equals to 36. Okay, and then next, of course, bila you are given with E, you need to find H. Okay, again to find H, please write down what is the general equation for H so that you can see what you need to find. Okay, so if we look into the H equations, all right, so we go back again. Where is your H? So this is your H. Okay, see. All right, please write the general equation for H. Mana dia tadi? Okay, this one. Okay, kita just saya just letak je kat sini. Alright, so general equation for H, so you have H naught sine omega t minus beta z ay. Alright, so first thing you need to determine what is the amplitude. So how to find the amplitude is by using these equations. So in order to find H naught, you need to find the intrinsic impedance. Okay, so again using the equation here, so refer back to your appendix, what is the equation for intrinsic impedance. Okay, and then substitute the value. So kamu tahu dia punya mu r is 1. So for non-magnetic material, the mu r will be equals to 1. Okay, saya rasa ada tulis dalam appendix. So refer back. So 4 pi times 10 power of 7 times divide by 36. 36 is epsilon r yang kamu cari tadi, and then this is epsilon naught. Okay, and then you will get this value. Alright, so so kamu dah cari H naught, and then next is, okay, so dah cari tu, you just substitute inside the equations lah. Alright, so don't forget to find what is the directions of your wave propagation, H directions. Okay, so again, AH is the one that you need to find what is the directions of AH. So AK cross dengan AE, so you know that the directions of AK just now is negative alpha Z. Okay, and then the directions of your AE is AY. Okay, AY, so the directions of your H will be AX. So AZ cross dengan AY will be negative AX. So negative dengan negative, it will be AX sahaja. So 0.796 sin 10 power of 8t plus 2z. And then theta dia tak ada. Theta n dia adalah 0 degree. So, oh hai, kenapa kat sini tak ada ya? Sekejap ya, saya refer back. Okay, sepatutnya here you need to have minus. Let's see. Okay, so please betulkan your equation. So H ZT dia equals to H naught sin omega T minus beta Z minus theta N. Okay, so please betulkan your equation.
Oh, so lossy dengan lossless sama lah dia punya tu. Okay.
Sama. Cumanya tadi mungkin dia tak letak because kalau ikutkan the general equation, you must have this theta n. Tapi mungkin because of the lossless medium, 0 degree for your intrinsic impedance, that's why dia dah hilangkan awal-awal. Tapi kalau ikutkan, the general equation is this one, minus theta n. Okay?
So maksud dia kalau general equation, dia ada apa, theta n tu, lossless. So possible lah kalau lossless dia ada selain daripada kosong degree.
Tak ada, dia memang kosong.
Dia memang kosong sajalah.
Memang kosong, that's why agaknya dia dah hilangkan awal-awal.
Okay.
Right, tapi I just want you to understand that the general equation must have this minus theta n. Betul lah, intrinsic impedance.
Okay.
Alright. Okay, so whatever it is, please refer your appendix ya. Dekat appendix tu saya rasa ada tulis. Ada tulis tak kat appendix? Ada kan? Theta n equals to 0.
Ada.
Okay. Alright, so next we have this lossy medium. So this example is a bit different sikit. Okay, so this example a bit different. So if you look into this one, a uniform plane wave in a lossy medium has a phase constant of this 1.6 radian. And this is the frequency 10 power of 7. And its magnitude is reduced by 60% for every 2 meter travel. So the magnitude ataupun the amplitude is reduced 60% for every 2 meter travel. Find the skin depth and the speed of the wave in the y direction. So this is a bit different sikit. Okay, so in this question dia dah mention that this is a lossy medium. Of course lah, because dia kata magnitude dia reduce 60% every 2 meter. Okay, kita tahu when the magnitude ataupun the amplitude reduce only happen dalam lossy medium sahaja. Okay, dalam free space dia tak akan reduce. Okay, so how to find the skin depth and the speed of the wave in the y directions. Alright, so if you look into the skin depth tadi, the equation is that 1 over alpha, right? Okay, so dia tak bagi kamu the equations of E ataupun the equations of your H. So it's difficult for you to determine what is your alpha. So how untuk cari, the other way untuk cari this alpha is by looking at apa lain yang dia bagi. So selain pada tu, dia bagi kamu phase constant, dia bagi frequency, and also this one for every 2. So reduce by 6 every travel. So this one you read back to your part. So this is your amplitude punya part where you have epsilon naught lah. E naught equals to epsilon negative alpha y. So alpha ni yang kamu nak cari, right? What is the value of alpha? So in here, so kalau kita tahu dia kata the magnitude is reduced by 60%, maknanya daripada 100% dia dah kurang 60%, yang hanya tinggal adalah 40%. Okay, so because of 40% saja yang tinggal, so you can put this value epsilon negative alpha y will be equals to 0.4 because 40% saja yang tinggal. Okay, so this epsilon negative alpha y is also known as the we can also find the percentage of the decrements of the wave propagations. Okay, negative alpha y. So kamu boleh guna this one, the percentage of the decrement. Okay, so you can use this equation. So E naught equals to epsilon negative alpha y, which is equal to epsilon naught 0.4 because hanya 40% sahaja yang left. Okay, so E naught dengan E naught we can cancel out. So you will have this. So epsilon negative alpha 2 equals to 0.4. 2 here because kita tahu dia kata every 2 meter travel. So y is the distance. Y is the distance. So kamu just masukkan 2 dekat y. Okay, y ni adalah berapa jauh yang dia pergi. Alright, so 2 is here. So you can have this one, epsilon negative alpha 2 equals to 0.4. So now how to get rid of this epsilon sebab kita nak cari alpha. Okay, so we just lonkan both part. Okay, sebab dia adalah epsilon. So epsilon dia adalah ln lah kan. Opposite way dia adalah ln. So kita lonkan both part. So we have ln E over here and we have ln 0.4 over here and we bring this negative alpha 2 ke depan because whatever yang ke atas ni bila kita lonkan dia akan ke depan kan. So negative alpha 2 ln E equals to ln 0.4. So from there okay, ln E equals to 1. Ln E sama dengan 1, right? So ln E equals to 1. So you just left with negative alpha 2 equals to ln 0.4. So for that, kamu nak cari alpha. Okay, so ln 0.4 will be negative 0.916 and this is negative 2. So you will get alpha is 0.458. Okay. And then bila dah cari alpha, so you can use the skin depth punya equation where 1 over alpha. So 1 over 0.458, you will get 2.183 meter. Alright. And then the next question is that skin depth saja yang saya ingat. Skin depth and the speed of the wave. So speed is u. So u again kamu cari dalam refer back to the equations. So u is omega over b. So you just substitute the omega and then the b is given to you. Omega tadi kamu boleh cari 2 pi f kan? F dia adalah 10 power of 7. So 2 pi times 10 power of 7 divided by beta. Beta is given to you 1.6. And you will get the value is 3.927. Okay. Alright, so the next one. Kita ada berapa banyak example ni? 4. Oh, 4 je Betul masuk tutorial. Okay, so the next one is a lossy dielectric ataupun low loss dielectric. So this is a lossy. Okay, so you look into the question again. A plane wave travelling in the plus y direction, positive y direction in lossy medium, and this is all the parameters. So again, kalau kamu tengokkan the equations over here, kamu boleh kata dia adalah lossless punya equation, right? Tapi again, kamu tengok dia dah cakap kat sini, this is a lossy medium. Okay, so lossy medium maknanya dia ada epsilon minus alpha z tadi. Okay, so you need to be careful of that. Okay, lossy medium, go back to the general equation and look again what is in the general equations. Because yang equation dia bagi kat kamu tu tak cukup. So mesti nanti dia suruh kamu cari. I think so. Okay, nanti we go through. Alright, so the first one, you need to find E at Y equals to 1 meter and then T equals to 2 nanosecond. Okay, so first, again, whatever, kalau soalan tu is a lossy medium, so first thing yang you need to do is to find the loss tangent sebab kamu nak determine whether dia adalah good conductor ataupun dia adalah lossy dielectric. Okay, so kamu kena determine tu. So first thing you need to remember untuk lossy medium punya question, you need to find the loss tangent. Okay, so using this equation, substitute all the value given to you. So you look here, the value is 0.09, which is less than 1. So of course this is a low loss dielectric. Okay, so because of that, go to your appendix and then refer to low loss dielectric punya part. Okay, so next that again, because next one, the question want you to find E at Y equals to 1 meter, T equals 2 nanosecond. So you need to again find the general equation ataupun the equations of E field. Okay, sebab yang E field yang dia bagi ni tak lengkap. Okay, so kalau kamu ambil the general equation, you must have this epsilon minus alpha z. So because of that, kamu kena cari all the value. Okay, so you need to find alpha, you need to find beta. Okay, so here how to find your alpha again? So you need to look into the equation in low loss dielectric. Okay, so you will find this equation. So substitute all the value yang ada and you will get this value untuk alpha. Okay, so same goes for beta. So substitute all the value yang given to you and then you will get the value for beta. Beta tadi dia tak bagi ya? Oh, tak ada. Okay. So this is intrinsic impedance punya value ni. Okay. So that's why kamu kena cari beta. So bila kamu dah dapat this value, okay, substitute into the general equation and you will have this general equation untuk soalan kamu. So you have 30 epsilon minus 0.943y. So this is your value of alpha tadi. And then cos. Okay, it can be sin ataupun it can be cos ya. Kalau dia given to you in cos, mana dia cos? Given to you in cos, so kamu kena tulis cos. Kalau dia given to you sin, so you need to use sin. So meaning that your your signal, your wave is dalam cos punya apa? Cos wave. Ada sine wave, ada cos wave kan? So kat mana dia start dulu and kat mana dia end. Okay, so for this one, this is a cos. So again, substitute all the equations, all the values, sorry. So you get this and then you have 20.95y, alright, plus pi over 4 az. Okay, and then the question want you to find y at 1 and t at 2. So bila dah y at 1, t at 2, just substitute lah inside the equation and you will get the value over here. Okay, so your E is 2.84 AZ. Alright. Okay, so what is the next questions? Okay, so again, the directions of wave tadi dia dah bagi plus positive directions. So that's why kamu gunakan semuanya y dekat your equation sini. So negative 30 E epsilon 0.943y. Okay, before this kita selalu guna z kan. So dia adalah direction dia adalah y. So sini pun y, sini pun y. Okay, because of dia adalah positive y. So kat sini adalah minus. Kalau dia kata directions adalah negative y, so dekat sini will be plus. Okay. Okay, apa next question dia? The distance travelled by the wave to a phase shift of 10 degree. And then the distance travelled by the wave to have its amplitude reduced by 40%. Okay, so yang the distance travelled by the wave to have its amplitude reduced by 40% ni sama macam yang soalan before. But the distance travelled by the wave to have phase shift of 10 degrees, so this one you need to refer at beta. Okay, sebab beta is the phase shift. Okay, so you can look into your beta. So beta y. Okay, y tadi kan the directions. So beta y is 10%. So 10% pula. 10 degree. Okay, so 10 degree kamu kena tukar kepada radian. So you will get, kamu kena darabkan dia. And then you can find your y after that. Okay, so beta y equals to 10% ni kamu tukar dalam radian dulu. And then you need to find, you can find your y. So your y is 8.325 mm. Okay, and then dia kata tadi distance travel when it reduced to 40%. So when it's reduced to 40%, yang left hanya 0.6% ataupun 0.6% pula. Yang left hanya 60%. So it will be 0.6 here. So buat cara yang sama juga. So this 30 and 30 will be okay, yang ni dia dah cari awal-awal pun boleh. So it will be 18. Okay. And then kamu gunakan ln E juga. So ln E equals to 1, negative alpha y equals to ln 0.6, y equals to 542 millimeter. Okay. Alright, so the last question, I assume that dia so cari H. Right, so to find H, you need to find the amplitude of H, and then to find amplitude of H, you need to have this intrinsic impedance. Alright, refer back to the equation table dalam your appendix. Okay, cari intrinsic impedance. Okay, and then cari dia punya theta n. What is a theta n? So dalam appendix tu semua ada, kamu just ambil and then gunakan je. Okay, so when you have all the value here, right, so substitute inside the equations, you can have this one. So this is your alpha, alpha plus, your H, sorry. This is your amplitude, this is your alpha. Alpha tadi kamu cari kan 0.943, and then again the same one cos 10 power of 9 your beta. Okay, minus this is omega, sorry. This is omega minus beta. Y plus dengan pi over 4 memang dah ada. So minus dengan 0.045 your intrinsic impedance. And then the directions is AX. So directions again refer back to this. Untuk cari directions of AH, AK must cross dengan AE. So you know that directions of AK tadi adalah Y, positive Y, and directions of your AE is Z directions. So AY cross dengan AZ, kamu akan dapat AX. So that's why your directions here is AX. Okay, so bila you already have this general equation untuk H, so dia suruh kamu cari Y at 2 and T at 2. Sama juga untuk E tadi. So just substitute inside Y and T. So you will get the final value of this one, negative 22.83 AX, milliampere per meter. Alright. Okay. So for this one, the last one is the tutorial part. Okay, so for tutorial part, I want you to do it. Alright, so I'm tak sure ada berapa soalan, probably ada 5 mungkin. Okay, so I want you to do it, try dulu, and then if you have any problem ataupun kamu tak boleh nak, tak tahu nak buat macam mana, you can ask me. Okay, but make sure that kamu buat dulu so I can see that kat mana mistake kamu. Alright, and then I will explain back to you later. Okay, so kita ada 1, 2, 3, 4, 5. Okay, ada 6. Mesti ada sampai Julai. Okay, so ada 6 soalan. Alright, so please do it all. Alright, so plane wave propagate in y directions of frequency through a material, blah 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 blah. Okay, so this one dia tak bagi kamu semua kan, dia tak bagi kamu equations. So I think what you can do is that you follow this step dulu. Plane wave propagate in 10 megahertz through a material with the following properties. Okay, so permeability is mu, permittivity is conductivity is this. Okay, determine the attenuation constant. Alright, so you need to find alpha. So refer back to the equations. Okay. Refer to the appendix. So tengok balik dekat mana, because for the lossless punya equation dia ada bagi tahu alpha berapa, conductivity berapa. So kalau dia ada value like this, so meaning that dia adalah lossless, right? Kalau conductivity dia ada lossless, ada value, maknanya dia adalah lossless medium. Because untuk lossless tak, saya selalu terbalik. Kalau conductivity dia ada value, meaning that dia adalah lossy medium. Okay, because lossless dia tak ada value untuk conductivity. Okay, so you refer macam tu dekat your appendix. Alright, and then macam mana kita nak determine whether dia adalah good conductor ataupun tak. Refer back kalau boleh relate dengan dia punya epsilon ataupun dia punya mu. Okay, next one is okay, ni dia ada cakap good conductor. Okay, so kamu buat dulu sebab saya pun akan buat juga. Alright, so kamu buat dulu. Nanti if you have any question, you can ask me. Alright. So ada soalan? Any question from you? Saya tak buat lagi, so saya tak nampak apa yang kena buat. Okay, so any questions?
No,
So,
madam.
okay. Please remember that your paper will be on 23rd kan? Betul ke 23rd? Ke 4th? Ke 3rd? Bila kamu punya final?
Kata benda cakap 3 Ogos je. 8 pagi.
Saya pun dah lupa dah, banyak sangat dah. Saya ni dah bermain dengan tarikh ni. Ya Allah, pening kepala saya. 3rd Ogos 3rd Ogos pagi. Okay, 3rd Ogos will be berapa lama lagi? 1, 2, 3. 3 weeks lagi. Paper apa lagi yang kamu ada? Paper lah, ada berapa paper kamu final?
4.
Ada 4. So paper electromagnetic wave, paper yang ke berapa?
Last.
Oh, last. Okay, last. So before paper EM wave, berapa hari kamu ada untuk study EM wave?
2.
Nangis. So kamu kena start dari sekarang tau. Okay? Paper apa yang kamu ada? Machine lagi?
Numerical.
Okay.
Power
system. Okay, paper yang sebelum dia?
Power system.
Alright. Okay, so if anything kamu can just can find me, kamu boleh tanya saya anything bila-bila, tapi janganlah pukul 11, pukul 10 ke saya dah tidur agaknya. Okay? Tapi you can just WhatsApp, mungkin saya akan jawab in the morning. Alright? Boleh ya? Okay?
Boleh.
So please do all the example balik and then refer balik yang semua kita dah discuss, all the tutorials. Okay, refer back. Ada kan semua dekat situ? So please refer back that one. And then apa lagi? Tu je kot kan? So tengok balik, buat balik semula. So make sure that you understand. Alright? Okay, so saya nak jumpa siapa semalam? Alia ya? Alia ada tak?
Saya ada.
Okay. Alia, kamu stay ya?
Baik, madam.
Baik, madam.
Masalah ni.
Okay, so thank you all. Anything kamu boleh cari saya ada kat sini, okay? Assalamualaikum.